On the test this Friday, you'll be given these 5 equations on your test. The key is knowing when to use each one. So this first 2 equations are used to find the terms. The first one is arithmetic because it has the common difference d. The second one is geometric because it has the common ratio r. All 3 of these formulas all have to do with a sum. These 2 are finite sums, the top one being arithmetic, the bottom one being geometric, and this last equation is a sum of an infinite geometric. Okay, so on 1 through 5, the directions say, state whether the given sequence is arithmetic or geometric. Find the 17th term of the sequence for numbers 1 and 2 only. So if it's arithmetic, it means that you're either adding or subtracting to get the next number. If it's geometric, you're multiplying by a common ratio to get the next number. So I'm trying to figure out what am I doing to get from 1 to 4. Well, I could either be adding or multiplying, so let's make a decision. To get from 1 to 4, I could add 3. If I keep adding 3, will I get 7? Yes. If I add 3 more, will I get 10? Yes. So this is arithmetic. Because it's arithmetic, it has a common difference. Your difference is, what did I have to do to get to the next term? I had to add 3. I'm also supposed to find the 17th term for problem number 1. So now that I know it's arithmetic, I'm going to come up and use this top equation. It's arithmetic, and this is my term equation. They want me to find the 17th term, so n is 17. T1 means the first term. The first term is 1 plus n. N is 17 minus 1 times 3, so that's my common difference. Then I simply just go to my calculator and I type this in. 1 plus parentheses 17 minus 1 times 3. And it tells me that my 17th term is going to equal the number 49. All right, number 2. I'm trying to figure out what am I doing to get from 8 to 4 to 2 to 1. Well, you might say I'm subtracting 4, because 8 take away 4 is 4, but is 4 take away 4 2? No, so it's not arithmetic, so then maybe it's geometric. What am I multiplying 8 by to get 4? Well, I'm multiplying by 1/2. Half of 8 is 4, half of 4 is 2, half of 2 is 1. So this is geometric, and my r is equal to 1/2. Remember, to find r, you just divide the first term by the second term. 4 divided by 8 is 1/2. Now it says I need to find the 17th term for problems 1 and 2. So I need to find the 17th term. Because it's geometric, I'm using this equation. This equation says to take the first term and multiply it by r raised to the n minus 1. So 17 minus 1. I'm going to go type this in my calculator. So I have 8 times 1/2 raised to the 17 minus 1. Now you don't actually have to type in 17 minus 1. Hopefully you know that that's just 16. So the answer is 1.220703.125 e to the negative 4. Remember, e to the negative 4 means I'm going to move my decimal place 4 places to the left. So if I do that, I'm going to get 0.123, so 3 zeros, and then I'm going to do 1, 2. So I moved 4 places left. 1, 2, 3, 4. So I filled in 3 zeros. I did a 1, and then I did a 2. Okay. Number 3, I'm trying to decide what am I doing to get from 30 to 26. Well, I know I could subtract 4. It's if I subtract 4 from 26, I get 22. If I subtract 4 from 22, I get 18. So this is arithmetic, and the common difference is negative 4. I don't need to go find the 17th term. I only had to do that for the first 2. On number 4, what am I doing to get from 17 to 21? Well, let's see. I could say I'm adding 4. 17 plus 4 is 21. 21 plus 4 is 25. So yeah, I'm adding 4. So this is arithmetic, and the common difference is plus 4. Okay. Number 5, I'm trying to get from 8 to 12. If I'm going from 8 to 12, I could say that I'm adding 8, 9, 10, 11, 4. But 12 plus 4 is not 18, so it's not arithmetic. So now I'm thinking it's geometric. Now I'm trying to figure out what did I multiply 8 by to get 12. Sometimes it's hard to figure out, so I told y'all to find r, you take the second term and divide it by the first term. Notice that equation is nowhere up here. You have to know this. So the second term is 12 divided by 8. So you can go to your calculator if you need to. 12 divided by 8, and then you're going to math bracket. So it's 3/2. So it's geometric, and r equals 3/2. The next set, it says use the formula for the general term, the nth term of an arithmetic sequence to find the indicated term. So they're telling me both these problems are arithmetic, and I'm going to be looking for an indicated term. That means I'm using this equation up here at the top. This is my arithmetic term equation. So number 6 wants me to find the 12th term. They tell me right there. They tell me my first term is 15 and my common difference is -4. So the 12th term equals, the first term is 15. I'm looking for the 12th term, and I'm going to multiply it by -4. So type that in my calculator. So it's 15 plus 12 minus 1 times -4. And we get -29. Okay, number 7. On number 7, they're asking you to find the 10th term. And again, they give me the first term, and they give me the common difference. So I'm plugging into the same formula. The 10th term equals the first term plus n, which is 10, minus 1 times the common difference of 8. So 15 plus 10 minus 1 times 8. The answer is 87. And that's it. It's just a matter of knowing which formula to use. Because it said arithmetic, and because they want me to find a term, term starts with t, so I need a t equation, and this is my arithmetic equation because it has the letter d for common difference. All right, 8 and 9 tell me to use the general formula for a geometric sequence to find the indicated term. Again, it says t, so I need an equation that starts with t. Geometric is the one that has the r in it. So I'm going to be using this equation. First term times r to the n minus 1. Okay, so they want me to find the 12th term. So the 12th term is equal to the first term times r to the n minus 1. I'm going to type that in my calculator. So 12 times 4 raised to the 12 minus 1. You get a large number. It's okay, we write the whole thing down. 0, 3, 3, 1, 6, 4, 8. Number 9, it's the exact same process. They want me to find the 10th term. So the 10th term equals, the formula says you write down the first term times r, which is 1/2, raised to the n minus 1, so 10 minus 1. Okay, so I'm going to type this in my calculator. So 24 times 1/2 raised to the 10 minus 1. 0.046875. That's not that long, so I'm going to write the whole thing. Alright, that's it. Alright, number 10 and 11 usually give you a little bit of problems. So it wants to know how many 4-digit numbers are multiples of 6. So the first thing you have to figure out is what is your first 4-digit number. So my first 4-digit number would be 1,000, and I need to know if it's divisible by 6. So 1,000 divisible by 6. Nope. Now try the next one. 1,001 divided by 6. Nope. 1,002 divided by 6. There it is. So the first 4-digit number I can divide by 6 is 1,002. So I'm going to go ahead and start my sequence. Okay. Now I'm going to go find the next 4-digit number. I just have to add 6, so that should be 1,008. I go add 6 again. And you just keep going. Now I need to know the last 4-digit number I can divide by 6. Well, my last 4-digit number is 9,999. That does not divide by 6. 9,998. Nope. 9,997. Nope. Oh wait, I didn't do that right. Yeah, I did. 9,996. Yep, there it is. That's the last 4-digit number I can divide by 6. And they want to know how many. If they're asking for how many, they're asking me to go find n. So I have to decide, is this arithmetic or geometric? Well, you'll notice as I go from 1002 to 1008 to 1014, I'm adding 6. So this is arithmetic, and the common difference is plus 6. So I'm going to go plug into my arithmetic equation. I'm going to go write it down again so we have it to look at. And I'm going to go solve for n. So Tn is your last term, which is 9,996, equals T1 is your first term, 1,002, plus n, that's what I'm looking for, minus 1 times d, which is 6. From here, we're going to go solve. The first thing I'm going to do is subtract 1,002. So 9,996 minus 1,002. So I have 8,994 equals 6 times n minus 1. A lot of y'all want to go distribute from here, so that's what I'll go do. It's not the only way to do it. Then you're going to add 6 to both sides. So you have 9,000 equals 6n. And you're going to divide by 6. So n equals 1,500. So there are 1,500 terms that are divisible by 6 between 1,002 and 9,996. All right, number 3 is going to work the same way. Pause the video, try it on your own, and then come back and check. So on number 11, they want to know how many 3-digit numbers are multiple of 7. So we're going to start off with the same process. The first 3-digit number I have is 100. Is that divisible by 7? Nope. Then I'm going to try 101. Is that divisible by 7? Nope. Try 102. I try 103 until I find the first one that I can divide by 7 evenly. So 105 is the first number I can divide by 7. So the first number is going to be 105, comma. I'm going to go add 7 more to get the next one. So 105 plus 7 is going to give me 112. Dot, dot, dot. Now I need to find the last number I can divide by 7. So 9999 is the last 3-digit number. That does not divide by 7. 9998. Nope. 9997. Nope. 9996. Nope. 995. Nope. 994. Up there it is. So 994 is the last one. Okay, we're going to do this one the exact same way. I'm using the same formula here. Remember, Tn means my last term. So 994 equals T1 is my first term. I'm solving for n, and my common difference. What was I doing to get from 105 to 112? I was adding 7. So we're going to go solve for n. So I'm going to subtract 105 first. You get 889 equals 7 n minus 1. I'm going to go distribute the 7. I'm going to get 889 equals 7n minus 7. I'm going to add 7. I get 896. And then I'm going to divide by 7 and get 128. Okay, so there are 128 terms that are divisible by 3 of my 3-digit numbers. On 12 and 13, the sequence is defined recursively. Give the first 4 terms of the sequence. So if something's defined recursively, they always give you the first term. So my first term is 5. Then it tells me right here, here's the definition, take the previous term and add 3. So if I add 3 to 5, I get 8. 3 to 8 is 11. And 3 to 11 is 14. 1, 2, 3, 4. I did the first 4 terms. You notice plus 3, plus 3, plus 3. Okay, for this problem, it says the first term is 2, and I have to find the next 3 terms. And it says I'm going to take the previous term and subtract 3. So 2 take away 3 is negative 1. Take away 3 more is negative 4. Take away 3 more is negative 7. And that's it. The recursive ones are really easy. On 14 and 15, it says for each of the arithmetic series, so they're telling me it's arithmetic, find the sum. So this time I'm going to use a different equation. I'm using this top one because it's arithmetic and it's for a sum. So I'm going to go rewrite the formula right here. So Sn equals in parentheses T1 plus Tn divided by 2. Okay, so they want me to find the sum of the 10th term. This is what they want. So S10 equals n, so the first n is 10, parentheses T1 is 3, T10 is 39 divided by 2. Okay, so I'm going to go plug that in. So 10 parentheses 3 plus 39, enter, divided by 2. And I get 210. Done. Okay, so for number 15, it's the exact same process. I need to find the number of terms, the first term, the last term, divided by 2. Well, I already know the first term. I already know the last term, but before I can solve this problem, I have to go find n. Because it's arithmetic, I'm going to also use this formula to solve for n. So the first thing I'm going to do is solve for n. Once I have n, I'm going to go plug into this formula. Okay, so to solve for n, I'm going to take my last term, which is 99, equals my first term, plus n minus 1 times the common difference. What am I doing to get from 3 to 7? I'm adding 4. Okay, so we've done this a couple times. So I'm going to subtract 3 and get 96. I'm going to distribute and get 4n minus 4. I'm going to add 4 and get 100 equals 4n, and n equals 25. All right, now that I know that n is 25, and I know the first term and the last term, I can plug into this equation right here. All right, so I'm going to go do it right here. So the sum of the first 25 terms is equal to 25 parentheses 3 plus 99, all divided by 2. Okay, so we've got 25 parentheses 3 plus 99, enter, divided by 2, is 1,275. Okay, that's the final answer for number 15. Number 16 wants me to find n is 25 terms in the arithmetic sequence, and they want me to find the sum of the first 25 terms. So the sum of the first 25 terms. I know that n is 25. My first term is 3. Oh, I don't know my last term. Okay, so I'm going to use that same equation I used over here to find my last term. So the 25th term is equal to the first term plus n is 25, minus 1 times d. What are we doing to get from 3 to 11 to 19? We're adding 8, so my common difference is 8. So I'm going to use my calculator, 3 plus parentheses 25 minus 1 times 8, which is 195. Okay, so now that I know my 25th term, I'm going to go plug it back right in here. I'm going to go back to my calculator again, 25 parentheses 3 plus 195, enter, divided by 2. So the sum is 2,475. The final answer is 2,475. All right, 17, last one. They want me to find the sum of the first 45 terms, and they gave me an equation. So the sum of the first 45 terms equals, remember, I'm going to do n first, which is 45. Then I'm going to do my first term plus my last term divided by 2. Well, they gave me an equation right here. So I'm going to plug in 1. So 8 times 1 plus 2. So my first term is 10. And then I'm going to plug in 45. 8 times 45 plus 2. My last term is 362. And then I'm just going to type the whole thing in. So 45, parentheses 10 plus 362, enter, divided by 2. So the sum of the first 45 terms is 8,370. All right, so let's go look at the back of the review now. So we have one word problem, and you will have one word problem on your test. It says Jake is creating a mosaic piece of artwork. It will have a total of 18 rows. The bottom row requires 130 blue tiles. Each successive row requires 4 less tiles than the prior row. How many blue tiles will Jake need to purchase to create the mosaic? All right, so we start a sequence. So how many tiles will I need for the very bottom row? I'm going to need 130, okay? And then as I go up, I'm going to need, what does it say, 4 less. So what is 4 less than 130? 126. And what's 4 less than that? 122. Dot, 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 until I don't have any more. Okay, so they want to know how many total, which means it's going to be a sum. And I was adding to get the next term, so it's going to be an arithmetic sum. And I need to know the sum of 18 rows. They told me it was 18. So my n is 18. 18. The first term is 130. Uh-oh, I don't know the last term. That's what I'm going to have to go find. Because it's arithmetic, I'm going to use this equation right here. Okay, my first term is 130. My n is 18. That's my last term. That's my last row. And my common difference was times -4. Okay, so we got 130 plus 18 minus 1 times -4. So my last term is 62. Okay, now I'm going to go type that in. So 130 plus, 18, using this one, parentheses, 130 plus 62, enter, divided by 2. I need 1,728 tiles to create this mosaic. Okay, on 19 through 22, we're going to remember Bobo, Botan, eats, DC. Okay, and you only need this when I've got a fraction with x's on top and bottom. So 19 has a fraction, and it's got x's on top and bottom. And I'm looking at the exponents. Are the exponents bigger on top, bigger on bottom, or are they exactly the same? So the biggest one on top is x to the first. The biggest one on bottom is x to the first. If the exponents are exactly the same, you divide the coefficients. So 2 divided by 6 equals 1/3. All right, number 20. The biggest exponent on top is 2. The biggest exponent on bottom is 1. Are they bigger on top or bigger on bottom? They're bigger on top, so there is no limit. We're going to say it goes off to infinity. Okay, I have 2x to the first and 6x squared. Is it bigger on top or bigger on bottom? This time the exponent's bigger on the bottom, so it equals 0. Now this is not an exponent on top and bottom written as a fraction. This is a number less than 1 being raised to a power. If you have a number less than 1 being raised to the power and you forget it, let's say you forget the rule, you can just go type it in your calculator, 0.999 raised to the x, and you're going to go look at your table. Oops, hold on. We're going to go look at our table and see, are the numbers getting bigger or are they getting smaller? So as I go look at my table, you'll notice they're getting smaller and smaller and smaller, and as I hold down my finger, they continue to get smaller. So they're going to get closer and closer and closer to 0. Okay. On 23 and 24, this is what we actually covered this week, so this is probably a little fresher in your head. It says find the sum of the given infinite geometric series. Because it says infinite, I'm going to use the equation that's right here that doesn't have the n. Just s equals t1 over 1 minus r. Okay, so s equals, the first term is 24 over 1 minus, I have to go find r. Remember, to find r, it's the second term divided by the first term. So negative 12 divided by 24, which is negative 0.5. Because it's a negative, make sure you put it in parentheses. When you type this in your calculator, you have to remember to put an extra set of parentheses right here. So we're going to have 24 divided by parentheses, 1 minus parentheses, negative 0.5, close them. And we're going to get 16. Okay, 24 is going to work the same way, same formula. S equals the first term over 1 minus r. Okay, so I'm going to go type in 3/5, second term, divided by the first term. And we get 0.2. This time it's positive. Same thing though, I have to know to go put this in parentheses. It's not written in the formula. You have to know to go add these. So 3 divided by parentheses, 1 minus 0.2. And we get 3.75, or we could math bracket if we wanted to, and get 15 over 4. Both answers are correct. I'm going to write them both. 3.75 or 15 over 4. All right, 25 and 26 simply want me to write out the sum, do not solve. So all I have to do is go plug in. So I have to know how the sigma notation works. This tells me where my k value will start with. This tells me what my k value will end with. So I'm going to go plug in 1, 2, 3, 4, 5, and 6, one at a time. So if I plug in a 1 here, 1 plus 2 is 3. Now I'm going to go plug in 2. If I go plug in a 2, I get 4. If I go plug in a 3, I get 5. If I go plug in a 4, I get 6. If I go plug in a 5, I get 7. And if I go plug in 6, I get 8. So this is where k equals 1, 2, 3, 4, 5, 6. They just want me to write it out. They didn't actually ask me to go find the sum. This is what it looks like when you write it out. If I wanted you to find the sum, you could simply just add those up and type them in your calculator. 26 is going to work the same way. I'm going to start with 1 and I'm going to go off to infinity. So since I'm going to go off to infinity, I just do it 3 or 4 times. So I'm going to go plug in 1. So 1 plus 2 would be 3. I'm going to go plug in 2. 2 plus 2 would be 4. I'm going to go plug in 3. 3 plus 2 would be 5. Plus dot, dot, dot. I'm going to go plug in n, and it would be n plus 2. On 27, 28, and 29, they want you to write this using sigma notation. So on 23, first thing we write is sigma. I can tell that these are multiples of 4, so I'm going to let k equal 1. 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. It's going to stop at 5, and it's going to be 4 times whatever the k value is. Now this will most likely be multiple choice. You'll just look at each of your answer choices until you find the one that matches. On 28, I can see that my signs are changing, and usually when my signs are changing, it means that I'm going to have a negative being raised to a power. Okay? So this one we're going to have k equaling 1. 1, 2, 3, 4, 5, 6. I'm going to do it 6 times. And it looks like I'm multiplying by a halves. The only problem is that I have a 1 here. So I know if I had negative 1/2 to the k, well, I know that if k was 1, this would need to be a negative 1/2 to start with. So I have to multiply by something out here in order to get a positive 1. So negative 1/2 times negative 2 would give me a positive 1. So this is one way to write it. Again, it's multiple choice. You can look at your answer choices and see what it works. So then if I were to plug in a 2 here, negative 1/2 squared would be 1/4, and 1/4 times -2 would be -1/2. So this actually does work. All right, the next one, I've got 5 squared, 6 squared, 7 squared. So this time it doesn't even look like I start with a 1. It looks like I'm starting with k equaling to 5, and it's going all the way to 15. And it looks like all I'm really doing is saying k to the 2nd power. One more time, these will all be multiple choice. So you'll look at all your answer choices and plug your values in and see which one actually gives you the sum that you're supposed to get. Okay, so hopefully that helps. We had a review in class on Wednesday, and this is the video over review day 2. Study hard, my friends.